Hi, this is a video about the average of a function. And yes, I hope you're going to learn what that is. At least that's my intention. So there we go. So you should think of a function like this. And what does it mean to be the average of that function? Well, first of all, we look usually then to a function restricted to an interval. And then you could wonder, so think of this as the height. So what's sort of the average height of this function? Yeah, it should be somewhere here. Well, but somewhere here is not very precise. So the way it's defined is to say, okay, make a rectangle like this, of which the height, of which the area is exactly the same as the area under the graph. So what would that mean? If so, the average of f, which I denote with a little bar on top, the average of f times the width. Now the width of the interval here might be just b minus a, and that should be equal to the area under the graph, which is the integral over f. Okay, but once we agreed that this is the meaning of the average, then we get actually a formula by dividing by b minus h, and we get the average value of f is the integral over f on this interval. Let's put the boundaries there and here as well, the integral over the interval, and then divided by the width of the interval. Right? This multiplication here is simply the height of the rectangle times the width of the rectangle. And then by dividing by the width, we get the height, and that's the average of f. Okay, why does that make sense? Actually, let me just say a little word on why that makes sense. Suppose you do this just for numbers. I have the numbers 3, 5, 7, and another 5. Then I could actually make a little bar chart of this. Let's say this is the ground, and this is height 3, and then height 5, height 7, and height 5, right? 3, 5, 7, and 5. And then if I want the average of those numbers, then you would sort of do the same. You would try to make this into a rectangle. You would actually move this little bit. You would move it over there to get this rectangle, and the height of that rectangle would be exactly your average, 5 in this case. Right? So actually you do the same here, but then for the continuous case. Okay, so once you agree with me that this formula really makes sense, then yeah, the example should be really straightforward. So now let's look at a case where the boundaries a equals 0 and b equals 2. The graph you're looking at here was actually my attempt to draw a graph of this parabola. So this is a reasonable representation. And there you go. What we need to do here is then to compute the average of f on this interval is integrate from 0 to 2 this function, and then divide by the width of the interval, which in this case is 2 minus 0, or 2. So that is 1/2 times the integral from 0 to 2 of 2x minus x squared dx. And from here it's really straightforward, I hope, computation of an integral. So antiderivative of 2x is x squared. Antiderivative of x squared is 1/3 times x cubed. And then we put the boundary values in there, 0 and 2, and we get 1/2 times, and then I open my bracket, I plug in the 2 here, I get 4 minus 8/3, like that. And that must be, well, 4 is 12/3, so I get 1/2 times 4/3, and my answer is 2/3. Does that make sense? Let's see, this parabola actually should have an extreme and a maximum in the middle, so for x equals 1. If I plug x equal 1 in here, the height is 1. So actually this maximum here is 1. So I'm not unhappy with this average of 2/3. I hope you're not unhappy either, and that you sort of picked up how to compute averages of functions on interval with this video.